Okay. Well, hello, everybody, and welcome to the Tom and Lonnie chat. I'm Dr. Tom Kerfus over at Georgia Tech, and let's see if we can bring on my friend and colleague. There he is, Doctor. There he is over there, at least
hey, Tom.
Dr. Lonnie Love.
How's it
Hello,
going, buddy?
Lonnie. Good to see you. Coming in from Sandia National Laboratories all the way out there in New Mexico. And let's see, our friend Stephen LaMarca from AMT. There he is.
What up?
Hey, all right. But, I mean, I got to say, then it's been interesting, engaging and introducing you guys. And, of course, we're going to learn some new stuff. But I am very excited today about our special guest star, another AMT employee. Let's see. There's Chloe Radigan. Hey, Chloe, how are you?
How's it going, guys?
Excellent. Excellent. And I'll tell you what, since Stephen is the guy who kind of knows all about this stuff and so forth, I'm going to let him do the big intro in terms of what Chloe's going to talk about, and then we're going to hear some pretty cool stuff. Stephen.
Yes. So we invited Chloe on today to talk about current developments and some really exciting projects that we have going on at the AMT test bed, which is our, I already forgot the number you gave me before we started recording, Tom, but our 18 square foot manufacturing facility here at the AMT HQ, our test bed.
2,600 square inches to make it sound
2,600 square inches. It started back in 2016 as just a first generation Pocket NC, which at the time the company that created it was still called Pocket NC, but now they go by Penta, and we're actually on our second machine because the first machine we sent to the Monterey Tech Center in Mexico. Oh. But that's I digress. Our current test bed is a 3 by 6 foot steel workbench with a more modern Pocket NC, an enclosure that it goes in, which a Pocket NC, by the way, is a horizontal 5-axis CNC machine. It is supplemented by a 6 degree of freedom collaborative robot, a Rebel 6, which is provided by, we purchased from IGUS. And that has, thanks to Chloe, has had a Intel RealSense vision system installed on it. And our most recent purchase for the test bed, actually, I don't know if it was before or after the vision system, but we got this really big computer, for really powerful computer that I was actually, I think Kyle Salibi and Tom Feldhausen.
Kyle Salibi is,
our co-host who's not currently present, but and him, and when I visited you guys at Georgia Tech and Kyle and Tom Feldhausen at Oak Ridge National Lab, I was nerding out, drooling over some of their computers that they have supplement their CNC machines over there. And we have since built our own really powerful workstation computer for doing digital twin work and simulation. But the test bed started back in 2016 with 3 goals in mind. The first one as a means of education for AMT staff. There's a lot of younger staff here at AMT, at one time, myself included, that did not come from the manufacturing industry. And we had to kind of hit the ground running, learning about machine tools and what the U.S. manufacturing industry has to offer and how to talk shop with our members and fellow attendees at industry events. This was a great help for that. One of my goals with the test bed in terms of education, just as a baseline, I'd like new employees to be able to look at the Pocket NC on the test bed and know that it's a milling machine and not a 3D printer, and that the tool in the tool holder is not, in fact, not a drill bit, but it's called an end mill. That's like the baseline to get people started here. And then if people are interested, which we've got some solid interest here at AMT, they're more than welcome to try their hand at making some stuff. But other than education, our second goal is as a proof of concept. We like to test and validate MTConnect processes on our test bed. So all of our machines on and devices on the test bed have an MTConnect agent and adapter installed on them. And that brings me to our third point, which is being that AMT is the primary supporter and owner of the MTConnect Institute. If we are to assist better with MTConnect customer support, we should be able to use it ourselves. And what better way to use a product than having a test bed for it? Those were the original goals. Chloe can help me fill in on some of the current projects we're working on and some of our more modern goals for the test bed.
Excellent. No, I think it's great. Thank you, Stephen, for waxing so poetic about this. I hope there's still something for Chloe to talk about. So,
oh my God, just wait.
By the way, I'll just say one quick thing. If you haven't seen some of these pocket machines, what's the company name now for Pocket NC?
Yeah, the company is Penta Machine Company, and the Pocket NC was their first product.
They are totally cool. If we have some time at the end, I'll tell you a very funny story about when I was at a conference out in the West Coast. We brought one of those. We just packed it in a suitcase and brought it with us to a conference not too long ago. I'll tell you about that story if we have time, but I think we want to let Chloe say a few things over there. Chloe.
Yeah, for sure. So now the test bed is still geared towards an educational sense, but more in a modern manufacturing environment, I'd say. We're working on a couple projects just involving computer vision in manufacturing, digital twins and simulation design kind of, and how the data interacts with each other.
Great.
I think one of Chloe's most recent projects with the vision system, we had to produce literally hundreds of photos for you to draw bounding boxes so the vision system could recognize stock, right?
Well, yeah. So we're building up a custom data set, and it's from scratch, right? To train a vision system. And for our specific model, you needed, more than what was it, 1,500 images or something.
Oh man.
Was the recommended. Now, is that exactly what you need? I'm not entirely convinced. Where it was in our case with bar stock. Yeah. And so we've done, a couple iterations of tests with different ways of data engineering to see if we can bring that down and what's actually effective.
So Chloe, when you're training, what's the objective of the training? What are you hoping that your system learns?
It's mostly about object detection and instance segmentation. So it's IDing the actual piece of bar stock. It's IDing a machine. It's IDing a robot. And it's telling you where in that space it's located.
And these are, I'm actually getting to sort of, I want to sort of jump out with the big headline, but these are things that you might just see. I mean, the stuff you're training and so forth, this kind of equipment now is starting to show up in lots of different shops and so forth, or not yet?
I think it's fairly prevalent in lots of places, and it's not just manufacturing that it's in. I mean, you're talking, I think one of the most applicable situations is the self-driving cars. That's where computer vision is mainly. And
so we're seeing these all over the place and so forth, including in shops and for robots and machine tools. And I hear we need lots of data. I hear training, and the little light bulb goes off. AI. Are we talking AI here?
Probably a little bit of AI. What's your definition of AI?
Well, we got to do some learning, got to do some training, and it's, you said it's going to learn about this piece and that piece, so it knows how to pick it up and where it's at. I mean, I guess my point is, hey, it's getting in there. It's getting everywhere. I mean, it's not taken over yet. I don't think we have to worry about the Skynet. Am I allowed to say that on the but I mean, I think, to the point, it's okay. Now it's starting to get in there, and it's learning about where to go to pick up the piece, what piece I have, which machine I'm looking at. I'm also guessing that it's also learning, the door is closed on the machine. Don't try and load it with the robot until the door opens and things like that. So again, simple things, but it's coming.
Chloe, how much would it cost to replicate this? If you wanted to have a whole kind of crowdsourcing approach to solving some of these problems and somebody wanted to participate, what do you think it would cost to replicate?
Replicate their like manufacturing environment, or
No, I mean, so your this Pocket NC, if I wanted to have a little shop, a mock shop like what you're doing it for kind of training and evaluating things. But I think there's also, I mean, that training can be democratized and you can leverage it. I'm curious if you basically created a kind of a blueprint for how to make one of these little work cells. I'm just curious how much it would cost. How much do you think it would cost?
I think Steve might have the answer there to that one, because
if I may,
responsible for sourcing all that.
Yeah. While we haven't done this calculation in a few years, the last time we did, we actually published a white paper on it, because that is another one of our goals, is to show that creating a test bed is actually super accessible, and that nobody has any excuse to not have a test bed.
Yeah.
And back when the white paper was published, we actually had that was still on our first Pocket NC, and our first robot, which the robot before the IGUS robot was a U-Factory X-Arm 7. And at the time that Russ and Sharab and myself threw that white paper together, our test bed, I think, was in total right around $20K.
Okay.
And that also leads me to mention that our test bed also runs purposely on a very limited budget. And we also don't really take, I don't know how to say this better than taking handouts, but we also don't accept like gifts or technology from companies that would be like, oh, well, how about we loan this to you? And our plan is to like buy the tech outright. So that not just to manage expectations, to be like, we can't do all of this, but to also show that you can buy a 5-axis CNC mill for less than $10K. You can buy a 6-joint, 7-joint collaborative robot for less than $10K, which is the really impressive one today. You can have when we were buying that workstation computer to run NVIDIA Omniverse, which I can't wait for Chloe to go on about that. But when we were looking for our computer, when we were shopping around for our computer, we looked at the NVIDIA Omniverse and Isaac Sim system requirements, and it basically that requires a $2,000 to $3,000 GPU alone, not even the whole computer. And when we looked at our IT department's compute PC supplier, and we told them these were the specs we need to meet. They showed us the cheapest computer they showed us was a 9K computer. And that's why we ended up building our own, which we ended up building a manufacturing grade, industrial grade, cutting edge computer for, I think, $3,500.
Oh.
By sourcing the components yourself and building it yourself.
Steven, so tell us what you really think about this. No, I'm just kidding. But I went online over here, and you can get the Pocket NC. I went over to Penta Machine, $6,900 for sort of the kind of wimpier version, if you will. But they've got as you were saying, $9,900. Well, there's a $9,900 one which is sort of beefier, got a 50,000 RPM spindle. It's pretty cool. And so, there you can actually really develop and check out some of the different stuff. Frankly speaking, right? You own a small machine shop, you get this and a couple of those other things, and all of a sudden you could, if you've got even a kid in high school or junior high, you could turn her loose over this stuff. Hey, play around with this thing and learn about it. Or you got, even some of your machinists or techs over there would say, hey, why don't you play around with this thing? I think they'd have a lot of fun. You could even take it home for the weekend.
Oh, yeah.
What you just said is where I was going to go. Is about 15 years ago, for about a decade, I was very active in the first robotics program, the high school level. And at one point in time, we opened up the MDF to all the local high schools. We were printing parts. I got Stratasys to donate like $50,000 worth of materials. Industry donates a lot of equipment to FIRST. And I went to DOE at one point in time and said, I want to.
DOE is Department of Energy.
Yeah, I went to the Department of Energy because they were making big investments in advanced manufacturing. And I said, I want $500,000 to buy 3D printers for high schools. And we ended up getting about 4 or 5 different companies to kind of contribute and gave us great deals and ended up providing, I think we bought like 500 printers and put them in high schools. And that's where I'm going on this is like, I'd like to know more. I think what would be really interesting is to establish maybe this first robotics program. I haven't done it in a few years. I got old and it takes a lot of energy, which I don't have anymore. But I mean, there's on the order of last time I checked, it's millions of kids participate, thousands of high schools and junior high schools. And it's amazing. And when I looked at it, it's like a great exercise on teaching kids about manufacturing. And so I would really like to know more about this and who are the companies and see if there's a strategic partnership you could establish with FIRST or somebody like that.
So Stephen, if we wanted to go find that white paper, is it still out there somewhere?
It definitely is. I don't know where it is off the top of my head, but I can find it.
Yeah,
but I'll try to share it when we publish some show notes.
Maybe Chloe and Stephen, maybe it's time to update that white paper. I think it's very cool. We actually, I'll tell you the story that I was going to say before. So we've got a couple of these machines, and they're just sort of fun in the hope that you could play with them and mess with them, and it's great. I mean, of course, as with all things, you got to be careful. You got to wear your safety glasses. You don't want to stick your hands in there while it's machining and so forth. But we brought it to a conference on the West Coast, over in Silicon Valley, and we're sort of showing it off and so forth. And this was a few years ago, and people were looking and saying, "Oh, God, is that a 3D printer?" No, and they're watching. If you watch, I mean, I got to say, I'm mesmerized. I especially like lathes, right? But just watching a CNC lathe go and start with that hunk of bar stock and machine it down to whatever it might, you might make. People were mesmerized. We had a crowd around this thing. They're like, "Oh my God, this is like 3D printing, but backwards." They had never seen a machine tool, and they're all, familiar with 3D printing, thanks to guys like Lonnie, buying, 1,000, 1,000 things and getting up. But they hadn't seen a machine tool. And they're like, "Oh my gosh, this is a new thing. Are you patenting it?" And blah, blah, blah.
How crazy is it that people today look at a lathe, look at a CNC lathe, and it's like a 3D printer going in reverse, and you don't think it's like a potter, like molding clay, it's
fun.
Different time, man.
Yeah, we have
my public schools had great art programs.
Yeah, in fact, over here we build these are just 6061 T6 on a nice little CNC lathe, and then we press them together onto a pin, and wonderful. They make wonderful yo-yos. So I get in trouble actually when we run these because the students all they're all trying to do around the world, and they're banging their heads and they're putting dents in the wall. And my department head always calls me in and says, "You need to stop making these things." I said, "Just be glad I'm not making them out of stainless." So.
Will you highlight this or show this at IMTS next year or in 2 years?
Probably. We've done it in the past, and in fact, earlier I wanted to interrupt and say that the fun fact about the Pocket NC is the first time AMT, in 100 years of its existence, the supporters and owners of IMTS, the first time we ever brought a machine tool to our own show was in 2018. We brought a Pocket NC to it.
That's neat.
I love it.
Neat.
Yeah, I think it's a definite goal of ours to actually have something to present in 2026. And something I want to mention also is that we do everything open source as well. So that's a big part of it, I think.
Open source is it running? What system is it running? Do you know?
Like Windows.
So it's running on. It's not a Linux machine. It's a Windows real time.
Yeah, it's Windows.
And is it running ROS at all?
It's not ROS on it right now. We don't have that set up yet. I know with how do you say it, Steve? IGUS. They have their own. You
said it right, actually.
Yeah. Okay.
I'm always flip-flopping with the pronunciation.
Yeah. We are right now just using the interfaces provided by, the robot arm and the Pocket NC. But But as we get further down, and once we have this kind of computer vision established, then we'll start working on those connections.
I think it's so cool. Yeah. And those are sort of fun projects and yeah. And again, I would encourage you guys, I mean, as you put it together and so forth, I'd go back and take a look at that white paper and I would update the white paper.
Yeah.
It's definitely in the work. But before we shift gears, I'd actually like to shift gears first. And Chloe, could you tell Tom and Lonnie what we've been doing on the test bed with respect to NVIDIA Omniverse, Isaac Sim, and our just general work in modeling and digital twin simulation?
Yeah, we've been exploring, I think, to put it lightly. Really trying to understand what use it will be in manufacturing is fun. And trying to create our digital twins, be it like, are we importing data through MTConnect, and how does that kind of roadmap work? Is one of our target goals that I think Sharp would speak more to were he here. But the work's just starting and we're really excited. I know a couple of our guys were at the GTC earlier this week that NVIDIA hosted, where there was an emphasis on Omniverse and how it's playing in manufacturing. There were cool demonstrations from like Mercedes. And yeah, we're excited.
It's really cool, the work that Chloe and Sharab have been doing in NVIDIA Omniverse, because with all of the drive towards digital twin use in the manufacturing industry and how prevalent NVIDIA Omniverse has been, and the necessity of NVIDIA GPUs to doing this kind of work, it's allowed an opportunity for AMT to actually be talking more closely with a big company like NVIDIA, and because of that, we were able to get them to keynote MFG this year. But also, I think there's an amazing workforce opportunity here.
Yeah.
The amount of youths today that are into PC gaming and gaming in general, one of the biggest names in gaming, at least in terms of like graphics, is NVIDIA.
Oh, yeah.
And one of the key terms that all gamers love talking about is ray tracing. And ray tracing is the basically the laws of physics that adhere to how rays of light bounce off of different materials, reflect off of different materials, and refract through different materials. And that just makes games look prettier. But because the GPUs and the GPUs that NVIDIA is producing are adhering to laws of physics, opens the door for this thing that we call digital twin. And there's a great connection that's like being ready to be made between the new next generation of gamers and the manufacturing industry. That is absolutely an iron that is hot and that we need to strike immediately.
And it's really funny too. Like we're trying to simulate our testbed environment in Omniverse, right? And we'll leave Omniverse on for like, I don't know, we left it on for maybe 8 hours or something. And it went through like 36.4 something of, was it RAM, Steve? Or
gigs of RAM?
Gigs of RAM, which I mean almost took it out. And our computer was like almost all, even though we have like the recommended specs for it. So it's just like a heavy piece of equipment that you have on that computer.
Yeah.
And it's interesting to work with.
Well, I mean, let me put it in perspective, right? So you said 30 some gig, right? We used 8K to put Neil Armstrong on the moon, and so forth. But let me go back to ray tracing, and then we probably should sort of start to wrap it up. But just, Steve, but sort of this, the big dissertation about ray tracing and so forth, et cetera, et cetera. But just for normal machine shop people like me, right? I mean, that's why I just reached over. I got my pen, which I will use as my twin for my boring bar, and here is my part, my coffee cup, right? And so basically, if I want to, I'm not even caring about refracting and reflecting and all that sort of stuff, just where the light goes. You know what? If I can see it, that's where the light's going and coming and so forth. So that means I can see it, and I'm not going to smack into it. I can't go this way because I can't see it. I can go this way because I can see it going in there. And I just had this conversation this morning with a student who might have had a boring bar inside a very big long tube, and then said, okay, go to tool change without doing this, and then going to tool change. So whammo, right?
I respect.
We learn.
We all do it.
But that's, just sort of from a very utilitarian perspective, that's where ray tracing, hey, if I fire my beam, my laser, is it going to whack into anything, or is it going to get to where I need it to go? And that's it, But it's an easier, what I just said, pretty easy way to state it. But to solve that problem is a hard problem. Yeah.
Oh, no, absolutely.
Yeah, it's at your fingertips.
And I think the importance between something is like basic is just, well, not basic, but ray tracing, where we're just talking about how light moves through different materials or interacts with different materials. It started with ray tracing with NVIDIA for gamers and making games look prettier, but it still adheres to the laws of physics, and it starts with light. But what's going to happen next is what does the manufacturing industry want more of? They want more physics-based models because the weaknesses in simulation software are how it is within how different materials interact with each other. And that comes down to laws of physics. And if there is a GPU manufacturer out there that is focusing on creating silicon dies that are best equipped to handle the laws of physics, that's going to help that much better with digital twin work.
Well, and that combined with the fact that pretty soon we're going to have mined all the Bitcoin that's out there. So, we're going to have to figure out something to do with the GPUs after that. We'll be in good shape. Anyways. All right. So I think that we have learned some cool stuff. Let's see if we can't dig out that white paper and so forth. And really, I encourage you guys to update it, because it really, it's just some very cool stuff, and you can try things out. And like I said, I grew up in a machine shop. So when I was a kid, at my dad's machine shop and so forth, if he would have handed me a little bitty machine tool and said, hey, try this out. That's how we started to get some computers going onto our equipment. We used to punch paper tape, and, we had the Flexwriter, and then they gave me an Apple IIe, I think, and they said, hey, what can you do with this and so forth. It was great. This is the same type of thing. It's inexpensive. It's pretty safe. If you crash it, you can screw it back you could take it apart and screw it back together and so forth. It's a great opportunity to engage some of the younger folks. Maybe we ought to think about this going, putting one or a couple of these things in and figuring out what we could do in the educational area over at IMTS. That would be fun.
Yeah. I'd love a follow-up on this, maybe a secondary podcast where we do a live. Let's go into the shop. Let's see what it looks like and show us how it works.
Live broadcast from
broadcast.
We could probably host a on-site
awesome.
I'd really like to
at the test bed.
Yeah. We can run through vision systems, 3D capture to CAD, everything.
Yeah.
That'd be great.
I'd really like to do that, and I'd love to see this at IMTS. And like I said, I was just doing a quick search. There's like 3,500 high schools that participate in the first robotics competition.
Oh my God. Yeah, it's
close
insane.
to 100,000 students. And what's really good, the secret about FIRST is big companies donate a lot of equipment and a lot of material and a lot of money to the program. And National Instruments is a huge sponsor, and we can see if NVIDIA would be willing to sponsor and get this in the hands of the kids. It would be amazing.
It's not hard to get them interested.
No,
they love Fortnite.
Yeah. No,
this is awesome.
It's cool, and it brings together some great technology that people And by the way, some of the new tools coming out for programming the GPUs and so forth, and especially with AI, where you can, I mean, it's getting there where you could just say, hey, AI, whoever it might be, you know, can you write me a program to do this? And, you know, and in fact, I will tell you that we've played around with some of this. Can you write a program to do this? It'll come back and say, well, I need to know this or I need to know that. So it's, you know, you got to work with it, and then it'll give you something and you're like, well, no, that's not quite it. I mean, that's just sort of conversational. You know, can you tweak this? Can you tweak that? This is what I want, and so forth. But that's where it's going, and it's going to be easy, and really it's going to allow you to be very creative. I have an idea, and it's going to help you to implement it, as opposed to all the programming and worrying about whether you had 32.5 gig of memory or whatever the heck you're doing to fill it all up and so forth. It's exciting.
Yeah, it's super fun. I mean, we're going to be coming out with a couple articles pretty soon, I think, from somebody myself, who's not been in the industry long, doesn't really have a lot of background in kind of a software aspect, and how exactly that disconnect looks and how easy it is to get what we need using, you know, different like ChatGPT, Perplexity, whatever you have in AI stuff. Get to a finished product. Like,
so where would we go? But, you know, you're saying, well, we're putting out these papers and so forth. Where do we find these papers?
They will eventually be published on AMTonline.org.
And so could you just, I mean, if I go there, do they have, so AMT?
We should have one testbed article out.
But is it under like, oh yeah, there it is. So if you go to AMTonline.org, so AMT's, there's media, and there it is. If you go to the media one, there's white papers.
Cool.
And there you go.
There you go.
Wow. So easy, even a professor can deal with it. All right. Hey, everybody. I want to thank you, Chloe. Thank you so much. You know, Stephen, you know, as always, you know, it was really good. I mean, I wish I'd be a little bit more passionate about this, but
I'm sorry.
I think it's, no, it's okay. It's okay. But it was great. You know, thanks for keeping us all in line and so forth. And Chloe, really great stuff. Actually, we definitely need to, at least I think Lonnie is, you know, that's the golden idea there. You know, let's go and visit Chloe's, you know, facility and start to take a look at what's going on.
Yeah, guys, I would love to do a deep dive. Let's do it.
And maybe we do a few deep dives. I mean, we'll sort of see how things go. I think it's going to be a big hit. So anyways, everybody, great to see you. And we'll catch you next time on the Tom and Lonnie Chat. Stay safe.
See you guys.
Thanks, guys.
Thanks a lot, Chloe.
Bye, everybody.